Hello dear students, in this session we'll discuss about one numerical about design of flat slab. Okay, so we'll directly start with the design and we'll see one by one the clauses that we are required in IS code and we'll use that accordingly. Okay, so let's start with that problem statement. Okay, a continuous flat slab with a drop for a shopping mall is as shown in below figure. The size of column is 450 by 450 mm. Use M30 grade of concrete and Fe415 steel. Calculate total design moment for S1 as shown in figure and take live load as 4 kN per meter square and floor finish load as 1 kN per meter square. Okay, so this grid is given and we are supposed to design for this S1. Okay, and what are the dimensions are given? It is 6 meter by 6 meter. And these are the columns. Column dimension is 450 by 450 mm and we are supposed to take M30 grade of concrete and Fe415 steel. Live load and floor finish load is given. Okay, so we'll start. Since Fe415 steel is used and drop is provided, the maximum span to thickness ratio permitted is 32. So how come this 32? So it is according to IS code 456. I'll upload the IS code in the Google Classroom, or some of you also have this copy. Okay, in the previous semesters you have used this IS code. Okay, so for thickness of flat, if drop is provided then the maximum ratio of largest span to thickness shall be 40 if mild steel is used and 32 if Fe415 or Fe500 steel is used. For our case drop is provided, that's why we'll take 32 value for Fe415, and if drop is not provided then in that case we are supposed to multiply with a 0.9 to this 40 and 32 values. Okay, and in no case the thickness of flat slab shall be less than 125 mm. So limiting value is 125. So minimum value is 125. So you can take any value above 125. So according to calculation, if any value comes less than 125, then just directly take 125 mm is the thickness of flat slab. Okay, so we'll see that clause in the IS code. So it is in clause 31. So whatever the clauses from 31, so you are supposed to take all those clauses. So it is in page number 53. Okay, here flat slab. Okay, now in 31.2.1 thickness of flat slab. Okay, so whatever we have discussed in the that 0.9 multiplication value and whatever the minimum thickness criteria is given in this clause. Okay, so we'll take, and whatever span we are considering, it is larger span. Okay, here they have specified for this purpose the longer span shall be considered. So we are supposed to consider longer span, but in our case 6 meter by 6 meter is the panel width, so we'll take 6000 divided by 32, so we'll get the value of 187.50 mm. So we'll provide 190 mm thickness of slab and we'll assume a effective cover of 30 mm. So overall depth capital D is 190 plus 30 is equals to 220 mm. Okay, so this is the overall depth of slab. Then moving towards the load calculation, so live load and floor finish load is given, so we are supposed to take the self weight also. So here what we'll do, we'll consider this self weight criteria or self weight load for 1 meter length to 1 meter width. Okay, and depth we have calculated as 0.22. Okay, so 1 meter by 1 meter into 0.22 into 25. 25 is the density of concrete. So 5.5 kilonewton per meter square is the self weight we got. Then live load and floor finish load will take directly as given. So we'll get the total load of 10.5 kilonewton per meter square. So we'll multiply it with 1.5 to get the factored load. Okay, now we are supposed to calculate the movement. Okay, so for this movement calculation, we have to consider these two parameters. First one is design load W is equals to L2 into Ln into Wu. So what these values are, it is directly given in the IS code. So just open IS code. It will take 1 minute. So here in clause number 31.4.2. Okay, so in the direct design method, the total design moment for a span shall be determined for a strip bounded laterally by center line of panel on each side of a center line of supports. Okay, the absolute sum of positive and average negative bending moment in each direction shall be taken as m0 is equals to capital W into ln divided by 8. Now what is this capital W? So this capital W is the design load on area L2 into Ln. So what does Ln means? It is the clear span extending from face to face of columns, capitals, brackets or walls, but not less than 0.65 L1. Okay. What does this exactly means? It means there is a clear span extending from the face of column. So okay, this span extending from face of column is considered as Ln. Now here I have on one diagram, simple diagram. Okay, so this part is Ln. Okay, so we are supposed to subtract these values. Okay, this extended column part. Okay, we are supposed to subtract that part and we'll take the clear span extending from face of columns. Okay, so that is Ln. Okay, and that Ln value in no case shall be less than 0.65 L1. Okay, so you have to check that value also, whatever you have calculated by subtracting the column dimension, so it should not be less than 0.65 L1. Okay, and what does the L1 means? It is the length in the span in the direction of m0. So m0, so from what dimension we are supposed to consider m0? From longer dimension. So L1 in short is the longer direction in which direction we are supposed to consider m0, and L2 is the length transverse to L1. Okay, so now we'll get the W value by multiplying design load, that WU, into L2 into Ln. Okay, so we'll get this W, capital value W, and we'll get m0, that is total movement, is equals to W into Ln divided by 8. Okay, now in our case Ln is 6 minus 0.45 divided by 2 minus 0.45 divided by 2. 450 by 450 mm is the column dimension, so we are supposed to subtract it from the either sides. Okay, so we will get Ln as 5.55 meter. So L2 is 6 meter. Okay, transverse direction from Ln. So we'll get the capital W value 524.475 kilonewton, and we'll keep this value in this total moment calculation and we'll get this m0 value. Okay, now as per IS 456-2000, clause number 31.4.3, total negative moment is equals to 0.65 m0. So how come this 0.65 m0 value has came, and what is the total negative moment and positive moment? So we have this presentation that we have seen in the previous class, that what is the total positive and negative moment. Okay, now this, okay, the value of negative moment is calculated at the face of column. Okay, here we'll get the negative moment, and at the span or at the spans, the center of span will get the positive moment. Okay, so I have discussed this part in the previous sessions. And what does the 0.65, where from where that 0.65 and 0.35 value has came? It has came from this clause, negative and positive design moments. Okay, in an interior span, the total design moment m0 shall be distributed in the following proportions: negative design moment is 0.65, positive design moment is 0.35 for interior span. Just study very with a very much concentration. It is for interior span. Okay, this distribution is like that. But for an end span, okay, the total design moment m0 shall be distributed in the following proportions: for interior negative design moment, it is 0.75 minus 0.10 divided by 1 plus 1 upon alpha c. Likewise, what does the alpha c? Alpha c means this thing. Okay, so if anything you have to prepare, or the MCQ that you have to prepare for this design of flats, for this flat slab unit, you just thoroughly read IS code. Any I bet you any question, no question will come out of this IS code. Okay, so the clauses are important, and there is much more to ask in these clauses. Okay, so just thoroughly go through the IS code and read each and every clause which we have not used also. Okay, so that will be the preparation of MCQ for this flat slab unit. Okay, so we'll for we are supposed to calculate for S1 is interior panel only. So this is the distribution of moments. Okay, now moving towards short numerical. So point positive and negative moment we are supposed to calculate. So total negative moment is 0.65 m0. Okay, and positive design moment is 0.35 m0. Okay, now these movements we have calculated. Again we have to distribute these movements in column strip and middle strip. Okay, so for column strip and middle strip, again we'll go in the IS code. For just look each and every step we require IS code. Just 1 minute. For column strip we are supposed to consider 0.75 and 0.25 values. Just 1 minute. Now we are supposed to distribute this positive design moment and negative design moment in column strip and middle strip. So just go to page number 54, clause number 31 point, sorry, clause number 31.5.5. Okay, distribution of bending moment across the panel width. For column strip, negative moment at an interior support. At an interior support, the column strip shall be designed to resist 75% of the total negative moment in the panel at that support. Okay, so 0.75% is the total negative moment for the column strip, and what remaining 0.25%, so remaining 25% is for middle strip. Then this is for negative movement. Okay, and for positive movement in the column strip, for each span, column strip shall be designed to resist 60% of the total positive movement in the panel. Okay, so just remember this 75 and 60%. 75% values for negative movement and 75% 60% is the value for positive movements, and remaining movements are for middle strips. Okay, so from these clauses we will go to or will derive this table. Okay, it is common for all the values for interior panel. Okay, so 75 and 60, 75 is negative, 60% is for positive. So whatever the positive movements we have calculated, we'll consider those. Okay, and remaining values for middle strips. Okay, so we got the, we have this what our basic question that we have asked. So calculate total design moment for S1. So we have calculated design moment for S1. So we'll check for thickness of slab. The width of column strip is 3000 mm and depth is calculated as 190 mm. So MU limit as per IS 456 2000 in annexure D, it is for FA 415 steel and M30 grade of concrete, it is 0.138 FCK BD square. 0.138 FCK is 30, B is 3000, D is 190. So whatever the moment we have derived should be greater than the design moment. Okay, so MU limit should be greater than M0. M0 is the design moment, we have calculated as 363.85. Okay, that's why our calculated thickness of slab is in safer range. Okay, so this completes one numerical on design of flat slab, and we have seen the IS code clauses. So just go thoroughly with the IS code. Again I am repeating these things because for MCQ purpose the examiner will directly take the questions from IS code, and in online exam you are not supposed to refer the IS code. That's why. Okay, so just write the clauses or important values in your notebook, whatever we have discussed and whatever we have not discussed also. Okay, so if any doubts regarding this flat slab design and IS code clauses, then directly contact me. Okay, thank you.